Welcome to This Explainer. Look, as a cloud engineer, I know firsthand the absolute nightmare of single key rate limits. You know the feeling, your production system crashes right when you need it most. So today, we're building something much better. A resilient, enterprise-grade middleware solution. We're going to completely bypass those limits using a free API key rotation strategy right inside OpenClaw.
I mean, we've all been there, right? You deploy this fantastic, high-volume, automated AI agent workflow. It's humming along beautifully. And then, bam, everything halts, your free tier account or your standard API key hits that dreaded 429, too many requests error, and your entire application just crashes to a complete standstill. It's incredibly frustrating.
So here is our game plan for today. We'll start with the rate limit problem itself, then break down the round-robin architecture. After that, we dive into the actual steps, installing the CLI Proxy, setting up the dashboard, integrating it with OpenClaw, and finally testing and validation. Let's get right into it. Section 1. The rate limit problem. When you're deploying enterprise AI and agentic workflows, large language models demand massive request volumes. They're literally starving for tokens all the time. And standard API providers, well, they throttle you to protect their own infrastructure. That's exactly what causes that 429 too many requests error. A single API key maxes out its limit and boom, your workflow halts. Relying on just one key is a severe, costly bottleneck, and for professional reliability, it's just completely unacceptable. Moving to Section 2, Round-Robin Architecture Explained. To control costs and eliminate this downtime, without having to buy some massive enterprise tier on day one, we need an intelligent gateway. Picture the old way. A single API key hits a blocked request wall, and your traffic simply stops dead. Now look at the round-robin logic instead. The CLI Proxy sequentially distributes your successful traffic across multiple keys. It takes your incoming request and sends it to key 1. The next request goes to key 2, and so on. If one key suddenly maxes out and throws an error, the proxy just temporarily benches it and seamlessly routes traffic to the next available key. Zero downtime during peak hours and maximum throughput when traffic bursts. It's a total game changer. Here is the high-level, 4-step deployment process we're going to follow to get this architecture running. Oh, and quick pro tip before we start. For long-term server maintenance, always back up your proxy configuration files periodically. You absolutely do not want to lose your gateway settings if your host server ever goes offline.
All right, Section 3. Step 1. Installing the CLI Proxy.
First things first, open up the terminal on your VPS or local machine. Now, as a senior engineer, I highly recommend running a quick routine checkup to update your Docker containers safely, just to make sure your host OS packages are completely up to date before installing new middleware. Once you're good there, execute these commands to clone the official code from GitHub and deploy the Docker container on port 8317. And please, crucially, establish a strong management password. Securing your proxy dashboard with strict access controls is non-negotiable. This gateway literally holds the keys to your entire AI infrastructure. Finally, just verify it's running with a quick Docker PS.
Section 4. Step 2. Dashboard Setup.
With the container running, we get to the really crucial part, loading up those multiple free keys. Go ahead and log in via your VPS IP on port 8317. Create your management API key, uncomment the OpenAI compatibility, and then load in your keys. I'm talking like 10 free OpenRouter keys, for example. You'll also want to set a model name alias. Managing hundreds of concurrent keys this way really minimizes overhead and optimizes your server resources for high traffic. And hey, another great practice, look into caching common responses at your application layer to reduce API consumption even further. Plus, keep an eye on latency between the proxy and API providers so your response times stay exceptionally low.
Section 5. Step 3. OpenClaw Integration.
Now, we actually need to tell OpenClaw to route its heavy traffic through our new proxy gateway instead of going directly to the provider. Over in OpenClaw's Raw View Config tab, you're going to map your variables exactly like this. Point the base URL to your local proxy and use that alias you just created. Let's talk troubleshooting for a second. Notice the fallback model at the bottom? Adding OpenAI models there ensures zero downtime, even if every single proxy key somehow gets exhausted. Also, if you run into common API authentication failures down the line, always check your CLI Proxy error logs first. That'll tell you exactly which keys are exhausted or malfunctioning so you can swap them out instantly.
Section 6. Step 4. Testing and validation.
Let's actually validate this. We need to see how it builds long-term reliability under intense pressure, using a few specific custom prompts. Go ahead and drop this first prompt right into the OpenClaw chat box. We're asking it to write a Python script for round-robin rotation. This kicks off a really heavy, token-intensive coding output from the model. This is validation check 1. It evaluates the AI's coding capability, but more importantly, it confirms our proxy actually prevents rate limits during a really long response generation. We're stress testing the system's ability to maintain an uninterrupted connection without throwing a 429 error while streaming hundreds of tokens back to us.
Okay, now let's use this second custom prompt. We are forcing the AI to output complex technical concepts and generate a really lengthy, detailed explanation. This acts as validation check 2. Because this prompt demands a massive amount of tokens, it's the absolute perfect diagnostic to verify smooth key rotation in the background. If the output stutters or fails, you'll want to go read your error logs to see if a key was formatted incorrectly in the dashboard. But if it completes smoothly, your round-robin logic is absolutely flawless. Finally, let's test the system with this third prompt. We're asking it to write an entire system architecture document, focusing heavily on role-based access control and token rate limiting.
This is validation check 3, and it challenges the system with deep, enterprise-level security workflows. Speaking of which, configuring role-based access control for your internal teams is so vital. You can actually use an architecture like this proxy gateway to restrict which internal developers get access to high-cost models versus free-tier ones. If your setup survives this deep-thinking, token-heavy request without failing, your production architecture is incredibly rock-solid.
So, with your rate limits effectively bypassed and your continuous server uptime strictly secured, what massive automated AI workflows will you deploy next? You now have a resilient, scalable, and highly cost-effective middleware architecture that is completely ready to handle whatever high-volume agents you can dream up. Thanks for exploring this architecture with me in this explainer. Happy building!